So I just want to take a few minutes here at the start and take some questions from homeworks or whatnots. So I think we've assigned up through everything, and the 1 through 60 has now all been assigned. Do we have any questions from any of that? Yeah, Alejandra? Or Alondra, excuse me. 22? Sure. So it says 2 toy racetracks form concentric circles. Each track is divided into 15 identical sections. If the inside car travels 1.2 centimeters less than the outer car on each piece of track, how much bigger is the radius of the outside track compared to the inside track? Set up 2 equations using the arc length formula and use substitution to solve. Round your answer to the nearest hundredth. Okay. Well, I'm going to start by drawing a picture. What does it mean when it says concentric circles? Yeah, they're circles that share the same center. So like that would be an example. And what I'm going to do now is I'm just going to draw like one of these 15 identical sections. So far, so good? All right. What shape is that section looking like? It's like a sector, right? So the inner sector, I'm going to say, has radius that we'll label R1. The bigger sector has radius that we'll label R2. And then has arc length S1 and arc length S2 respectively. But they both have the same central angle theta. So far, so good there? Yes?
How do we know what theta is?
That's the central angle for the sector.
Okay, so just the main angle. There's no other angles. That's right.
All right. It says if the inside car travels 1.2, thank you. Alondra, Khalil. It says if the inside car travels 1.2 centimeters less than the outside car on each piece of track, what that's saying is that S1 is equal to S2 minus 1.2. Everybody's okay there? So it says the inside car travels 1.2 centimeters less than the outer car on each piece of track. So the arc length S1 is 1.2 less than the arc length for S2. Now what I'm going to do is I'm going to set up 2 equations. I'm just going to use the arc length formula. And I know that S1 is equal to S2 minus 1.2. So far, so good. And then since S2 is equal to R, or theta R2, I'm going to make another substitution and put this all into one equation. So far, so good. Alondra, you got some faces going. Where did I lose you at? What? Well, let's backtrack a minute. Where did I lose you at? Okay. So these two equations. So the directions say set up two equations using the arc length formula. So that's all I've done. So for the first piece here, I just said S1 is equal to R1 theta. And then for my second sector there, I said that S2 is equal to R2 theta. Is that okay? So that's just me using the arc length formula. Yes.
Theta is the central.
Right, as I've labeled in the picture. Right, exactly right. What I then did, Alondra, is I used this fact that we were told about here, and I substituted it in for the S1 here. That gives me the new set of equations right there. And then my last step before I got to where you told me things weren't going great was I saw that S2 is equal to R2 theta. So I substituted that in for the S2 in equation 1. So I just did like a substitution, which gets me to where I'm at here in red in my next step. Now this still looks to be a problem because I see two unknowns. I see R2 and R1, but just one equation, right? But if I look at this closely, it says how much bigger is the radius of the outside track compared to the inside track? So it's asking me for R2 minus R1. So I don't actually need to solve for R2 and then solve for R1. I can just solve for the difference of the two, because that's really what the question's asking for. So that's what I'm going to try to do then. So I'm going to start by subtracting the R1 theta to both sides, and then adding the 1.2 to both sides. And then we'll divide both sides by, or I can factor out the theta, since that's common to both terms. And then divide both sides by theta. And now all I'm left with is figuring out what theta is. Sound good? And once I have what theta is, I can plug that in and type it in my calculator and get my answer, right? Alondra, are we doing okay? All right. So what piece of information haven't we used yet that was given to us? That each piece of track is divided into 15 identical segments. So I'm going to use that to figure out what theta is. So how far is theta, or how far is like the whole circle? 360. But if I use the radian formula, so 360 in radians is just 2 pi, right? Everybody's okay with that? And if I divide that 360 15 identical sections, that would be that, right? So I'm going to just take 2 pi divided by 15. And that should be my answer. Now I have to be a little bit careful about how I type this into my calculator though. So I'm going to use the alpha y equals and then this n over d option to get the fraction command. So I can kind of type it in the same way it looks like on my sheet of paper. So when I do that, I get 28.6. Does that seem right? This is an even. I guess you guys don't know the answer to this any better than I do. Let me look it up real quick. Oh my gosh, I sure did. Yeah, good call. Thank you. It's because I wrote down 12. See? Let's change that. That probably makes a heck of a lot. I'm like, that seems too big considering that this was one of these tracks is only like 1.2 centimeters longer than the other. That seems much more likely. So 286. I like that. Would I expect you to do something this intricate on a test or a quiz or whatever? No. No. That was a lot. There's a lot of algebra, there's a lot of like reading and interpreting. Like there's almost nothing given to you for free in that story problem. It was all like, okay, now I have to take that what's given to me and like use that to figure out what theta is or figure out how to write my equation or there was a lot going on there. Alondra, is that okay-ish? Okay-ish. All right, we'll settle for okay-ish. Who else has questions from homeworks? Yeah, Nick. $29. 39. I think Nick's actually talking about something a little bit different either than 39. So let's just do this. I'm going to steal the problem setup. And we're just going to say like, actually, let's do that. So let's solve the triangle. So we need to find angle C. We need to, or I'm sorry, side C, angle A, and angle B. Sound good? All right. Which one should we find first? Side C. Great. How are we going to find side C? Pythagorean theorem, a squared plus b squared plus c, or equals c squared. So 12 squared plus 9 squared equals c squared. Got to remember the hypotenuse is always that last piece though, right? So 144 plus 81 equals c squared. That's 225 equals c squared, which is 15. You type that in your calculator if you didn't know that the square root of 225 is 15. Would not expect you to know that off the top of your head. It is, but unless you're a math teacher, you probably don't know that off the top of your head. Okay, what now? Does it matter which one we find next? No. Which one do you want to find next? What? Angle B? Sure. Okay. Relative to angle B, what sides do we know? What one? We know all of them. Okay, so let's pick two of them. Which two do you want to use? B and C, sure. Relative to angle B, what is side B and side C? Opposite and hypotenuse. So which trig function should we be using? Sine. So we'll say sine B equals opposite over hypotenuse. So far, so good. Now, how do I get rid of the sine that's wrapped around the angle B? Sine inverse, yes. So I'm going to do sine inverse to both sides. Sine inverse cancels sine. So we're left with angle B. So now it's calculator time. Before I type this into my calculator, what should I check? Yeah, I should check my mode and make sure I'm in degree mode. I am, but I switch back and forth all the time. If you've borrowed someone else's calculator, like Mr. Kulix, you definitely want to start by checking that. So when I do that, I get 3687. And then how am I going to find angle A? Yeah, I can just do 90 minus angle B, right? Because I know the two acute angles in a right triangle have to add to give us 180. So 5313. Feel good? This is what you're talking about, right? Alondra. Yeah, we can do 40. Come on, there you go. Okay, so this is like our setup for 40, right? So we're going to use the angle we know, which is angle B. Relative to angle B, we know side 2. Is side 2 opposite, adjacent, or hypotenuse? That's opposite. And the side we're looking for, is that adjacent or hypotenuse? Adjacent. So which trig function do we need to know or need to use for opposite and adjacent? Tangent. So we'll write tan 88 equals opposite over adjacent. Now to solve for side A, I'm going to multiply both sides by A to get it out of the denominator. And then divide both sides by tan 88 to get the A by itself. And then it's calculator time. So when I do that, I get about 0.24. Oops. Now that seems really like a weird number. Is that reasonable? Angle A is 2 degrees. Side B, which should be much bigger than side A, is 2. Yeah, I think that's probably reasonable, right? The smallest side is across from the smallest angle, and the smallest angle is way smaller than the middle angle, so I'd expect the smallest side to be way shorter than the middle side.
Did you go from 2 to 7 though?
Oh, yeah, I sure did, huh? Thanks, homie. Boy, I'm having a bad penmanship day. It's like the second time I've done that. So 0.07. Even smaller. That's fine. I'm sure it's correct. Alondra, does that feel okay, what we did there? So again, the trick is, like, draw the picture. Ask yourself, like, what stuff am I given to figure out the trig function you need? And then you're just solving for the missing spot, right? Anybody else with questions on stuffs? What's the conversion factor between degrees and radians and degrees?
180 over pi, pi over 180.
Pi over 180, 180 over pi, depending on whichever way you want to go.
Radians, we're going radians to degrees, it's pi over 180.
Other way around.
Pi over 180 when you're trying to get radians, 180 over pi.
Okay.
Correct.
And then I'll give you this.
Just think about it like units canceling, like in your chemistry class. So like if you have degrees to start with, degrees needs to be in the denominator. If you had radians to start with, radians needs to be in the denominator. That's the easy way to think about it, because now you've just linked it to something else you're probably familiar with doing.
That makes sense. I got that.
You ready to homework quiz this thing up?